Hi everyone, I'm Joel. I'm first of his name, Defender of the Realm. And today, thank you for coming, we're going to be talking about, how to build UI at scale. So I know a lot about this. This will be good. It won't be like my last talk. Now, one thing I want to talk about how I approach this talk is that during this, you're going to get more of a high-level view of this subject, more about things like the architecture, kind of the philosophy and the workflow, and not so much about the coding, just so we're setting some expectations. Now about me, I've done some video games, even done a little bit outside of the game industry. I know you've all played Go Pets Vacation Island for the Nintendo DS. You don't need to come up and tell me, please, I already know. But I did start specializing in user interface. So in 2011, I joined Riot Games where I did UI for League of Legends, which at that time was the biggest game in the world. After that, I went to Wargaming to work on World of Tanks, which was probably the second biggest game of the world. And then I landed at Firaxis. Now, you probably know Firaxis for a little series they have. Starts with somebody's name and the letter C. So you know what I'm talking about. You could say it with me. It's Sid Meier's Covert Action. I hear Sid is working on a remake of this as we speak. Now, as you probably deduced from the title of this talk, I did work on Marvel Midnight Suns. But this slide's boring. Let's talk about something else. So, is everybody ready and excited to hear about some user interface? I'll take what I can get. Now, if you happen to be the developer on this fine game that was made in, I think, 1978, I think it's either called Outlaw or Gunfighter. Wow, what a time to be doing user interface. Back then, you only had to put 2 numbers on the screen and ship it. Some might even say that this was a golden age for our little discipline. But things have changed over time. And the things that UI is now responsible for has grown exponentially. Things like in-game stores, game launchers, friend management, inventory management, and I don't know what's happening here, but we still have to support it. So let's talk a little bit about where this scale has come from in terms of UI responsibilities. So one is kind of the complexity of what we're doing. Typically, we kind of see this in HUDs. And certainly HUDs do more than they used to. But the complexity of it has probably been the biggest, right? We have health bars. Our health bars are more complex. We have a mini-map. The mini-map is more complex. And I would frame this as being a depth problem. Now contrast this with the sheer number of screens that we now have to create in our products. This is just a small sampling of some of the things that we did for Midnight Suns. And for all these screens, they may not do a whole lot, but there are a significant amount of them. And this is, I would frame as a breadth problem. Now, if we kind of compare the two of what's grown more, depth or breadth, I would say that breadth has outpaced depth by a very large margin. So for the things I'm talking with you today, yes, they will help you with your breadth problems, but they really shine when it comes to breadth. Oh, we're back at this slide already? A little bit about Midnight Suns. We launched this game at the end of the year of December 2022. In terms of UI at scale, we had to build around 150 screens on this game, and it's only a single player game. So it was a lot. So a lot of the things that I will be talking about pertain to what we kind of found out while building Midnight Suns. Now, there is actually another project that has used a lot of the stuff that I'm talking about as well, but that hasn't been announced, so just kind of think of that project as it's kind of just going out vacationing around the world, wants to find out who it is. But just know that there are 2 projects that are using these techniques. So back to our story with Midnight Suns. During one of our first milestones called First Playable, this was kind of the first inkling on the UI team that there was something, this game was going to be big. And then when we got to then when we got to our next milestone called vertical slice, when we took a look at what was asked from the UI team, this was our that's no moon moment. We knew that this was going to be, from a UI standpoint, the biggest game that Firaxis had ever produced. So we needed a plan. We wanted to see, is there a way for us to get ahead of kind of these problems a little bit earlier than later? And kind of from where we were coming from is that this was the team that made XCOM 2. And that game was done with Unreal Engine 3 and Scaleform. So we were going to be upgrading to Unreal Engine 4, and everything I'm talking about works great with Unreal 5. And we were just going to use UMG instead of Scaleform. So this was both good and bad. It meant that we didn't really have any kind of foundation to build off of, but it also meant that it gave us more freedom in what to experiment with. So one of the things we decided that we should tackle is that we want to simplify the development for UI by providing a good workflow. And I like to say is that what we're doing is that we're optimizing for developer time, because that's always probably the most critical resource that we never have enough of. We also wanted to see, could we reduce the amount of boilerplate that we were traditionally having to do when we were creating screens? Now, the reason for this is because let's say that you have, on average, 10 lines of code, 10 blueprint nodes per screen. Doesn't sound like a lot, but take that times 150, and that's 1,500 lines. So yes, there's a little bit of a cost to building that, but the bigger issue is just that when something needs to change in that boilerplate, as the project goes on, there are more and more places that you need to do it. And lastly, we needed help. Probably about the first 2 years of this development, we only had 2 full-time UI engineers. So that meant that we needed some help from gameplay and design, not really to help us build screens that we were going to ship with, but just to stand up screens so that we could unblock people and start testing different features of the game. And this kind of went into some of our thoughts about the development and workflow. Now, looking at all this, we had a decision to make. We could either kind of go with a more traditional approach like inheritance and see, could we make that just better for scale? Instead, we kind of took the road less traveled, and we wanted to go with a compositional approach. So if you wanted to find a component, it's that we're taking some functionality, we're putting it into a class that is very separate from others. The metaphor people like to use is that you're building Lego blocks, and then you can take those blocks and put them in different configurations in what you're building. And this one choice of ours really affected pretty much how we did everything else in terms of UI for the game. And so we called this system just UICS, User Interface Component System. Now, I have to warn you, this part's going to be a little bit dry. I'm going to try to go through it as fast as we can, so just stay with me. It's important for all the things we're going to be talking about later, but we'll get through this together. So just want to define some terms so we're on the same page. One is that we have a screen. So the screen is just the base of our UI system. If there's something visual that's UI, it's because it's attached to a screen. Widget, most of you probably know this because of Unreal Engine, but it's just a visual UI element. And then we have a control, which means that it's an interactable widget. So think of like a button. And lastly, so we're going to define a screen component, and this is a class that provides some functionality that you can add to a screen. So as you're adding components to screens, you're kind of giving them more functionality. Now, one thing about moving to components is that now you got to ask yourself, hey, I've got these screens, how do I define what components are in it? And so can the editor help us with that? Yeah, so if you were to make a screen in our system and go to its properties, this is what you'd see. You have an array here of screen components, and you can use the editor to kind of go in and add however many of the components you want for that screen. So this was a very big part of our workflow. So Next problem is how do we break UI implementation into components? So let's think about something like, let's say, an inventory screen. What are the things that we have to do for that? Well, one is we have to get data. We have to get the player's inventory items. Next is we have to display all those items, probably using a button. And then lastly, we need to respond to the user's action, right? When they click on an item, that can be we open a new screen, or it could be something like we drop that item from the player's inventory. So if we break it down like that, well, we've got 3 components here we could start building. So for getting data, we're going to define a data screen component, which in the editor, you can see it kind of looks like this. So its responsibilities is that it's going to retrieve data, and you can do this by you implement a data provider, which is just implementing how you're getting the data you want. That data is going to come back as an array of UObject pointers. The reason being is because at this level, we don't really need to know much about what the specifics of the data we're retrieving are. Whoever does get that data, though, it should know what to cast it to. Then we have optional filters and transforms. And when you fill everything out, it looks like that. The reason filters do what you think. Transforms are things like I need to sort the data in a certain way. The reason why we kind of broke it down by this is because once you've implemented a data provider, like here the players, it's then a lot less work to go in and add a filter or a transform to then manipulate the data. The reason for that is because as you're going to scale, one of the things you're likely going to see is, I guess you would call sort of, you're going to see a lot of different ways that your data is going to show up. For instance, you may have a screen where it's a leaderboard. I need to show all the players, but then you have a screen where you only show the friendly players because you're showing their inventory, and then one screen where you only show the local player. So this helps us iterate by kind of hitting those points a lot easier and with less effort. All right, we've got to display our data, so we're going to make something called a view screen component. And so what this is responsible for is for creating and caching all of our widgets, responsible of adding it to a container that we choose. It gives data to widgets, and something we found helpful is that it will provide delegates for when any widget that it created, hits something like if somebody clicks on a widget or hovers over it, the view screen component will then tell you, hey, here's the event that happened, here's the widget, here's the data. This helps simplify things because instead of having, say, an array of 10 widgets that you have to go add delegates to, you only have to list to the view component. So we also, in terms of selecting what container it goes to, we put in a widget selector, which will just go to your design view, and you can pick any widget that you've kind of put there. Now, one thing I want to point out here is that you may think that what I have highlighted here is like a T subclass of, right? That's usually what it looks like most in Unreal. Like you choose a class, but there's a little caret there, and what that means is that this is actually an instance of a widget. And so it looks, the definition for it is that. What this allows you for is that if you click the little caret, you get all the variables that widget has. And what this allows you to do is that if you have a screen where, say, you need this widget to do sort of a one-off thing, you can just set it there in the editor. So this is like a little more flexible than just choosing a class. And lastly, we got a really simple one here, the action screen component. So really, this one's just about it's gathering any data required for an action. In this example, it's going to open a screen. You can query it to see, hey, can this action, do you have all the data for it? And then you're responsible for executing the action. So we've got our 3 basic things set up. Next thing is communication. So let me see if I can go a little bit faster, kind of get through this. How do they communicate with each other? So one is we have some basic functions we can give it. Now, we've kind of talked about this before. You have to be on a screen, right? So if you're a screen, a widget, or a screen component, we're going to give you some functions. for you to get screen components from the screen you're on. So like this one get screen component, you give it a type, it'll give you the first component of that type. And there are a couple variations on that to get things that are more specific. These are also all available in Blueprint as well. So, second way is for delegates. And I'm not going to go through them, but the basic idea is that our components, when an event happens, they can fire off a delegate that somebody else can listen to. So when the data screen component is finished with its data, it sends a delegate called onDataRetrieve, and let's say that it sends that array of data out with it. Somebody else can listen to that and then do something in response. Lastly, something that was a big time saver for us, again using the editor, was that we had something called component selectors. And they look like this. They're basically variables you could add either in native or the blueprints. And they will give you, when you view them out in something like a widgets property, it'll give you a list of all the components that currently exist on the screen you're editing. And then from there, you can choose the exact one you want. So if you're wanting to listen to a very specific data component, you listen from here during runtime. You can just get it from the variable, and then you're good to go. So as we're almost out of it, as we're talking through some examples, just realize that I'm going to kind of abstract some of the things out that we'll be talking about. And in the background, when it comes to communication, it's one of these three things that are happening, even if I don't explicitly call it out. So let's start with an example. So this here is our character select screen. Very basic. What we want to have happen here is we want to get a list of characters that are unlocked, display them, and when somebody clicks on one of these characters, we're going to open another screen. In this case, we're just going to open a screen that shows the character's inventory. So our setup component-wise is going to look like this. We're going to have a data screen component, which when this screen constructs, is going to go and retrieve all the characters that we've unlocked. It'll send off a delegate saying, I'm finished. The view screen component is listening for that. It'll have that array of data of all the characters. It will create the buttons that you see and send the data to them so that their icons can appear like this. And when somebody goes and clicks on one of the widget, the view screen component will broadcast saying, this is the widget that was clicked, here's its data. The action screen component will then kind of take that and it will open the character inventory screen in response. So this is sort of the bread and butter of how a lot of our screens work. And the thing I'd like to point out, I had spoken before about reducing boilerplate. We're able to get this kind of setup without adding any additional blueprint or native code. So it's all data-driven, and that means that, well, we can do a lot without any boilerplate at all. Now, we do have one kind of problem here, though, is that we're in the character inventory. We need to know what character was selected, right? So now we're starting to get into the question of how do screens communicate? So in our character inventory screen, this is our setup. And we're going to add one more new type of component called an entry screen component. This one's really simple. It just holds a piece of data, and it can broadcast out saying, hey, my data's been changed. So doing this, once the action screen component on character select creates our new character inventory screen, it's going to go ask it, hey, give me your entry screen component. It now has access to that. It's going to send in the piece of data related to the character we clicked on. Then the character inventory screen, the entry screen component, will send off a broadcast saying, hey, my data's been updated. The data screen's listening for that, so it's going to look through and say, all right, I now know what character's been selected, and then it can retrieve the data for all the items of that character. So the great thing about this is that it really helps us simplify the interactions between our screens. Normally what you might have to do is that you have to know something about another screen you're interacting with, right? You have to type into something, that type changes, it can get complicated. But with this, you don't need to know anything about the screen that you're interacting with. All you need to know is just about the component that you want. And in this case, the only thing we need to know about is the enter screen component. We don't need to know about anything else. And because of that, it actually helps us in some of our iteration, because this one screen where we select a character, depending on where you open it up in the level, it can and wherever you open up in the level, it can go to it will create different screens. And the only thing that we do is that when that screen opens up, the character select, we just tell it, here's the screen you want to create. Everything else is the same. It just interacts with components, and that made us changing around where screens open up and interacting with them a lot easier. So I want to give an example of kind of a case where we can share functionality across different types of screens. Now, I want to say you can put any type of functionality you want into a component. So in this case, we're in one of our inventory screens, and what we want to have happen is that we've selected Captain America, but if somebody clicks one of those two arrows, we want it to go to the next character in our list. So just sort of an easy navigation thing. So here's kind of just the regular setup for this screen. So to add this kind of cycling functionality, we're going to add two more components. We're going to add a data screen component where it's going to get the list of characters that are unlocked, which, hey, we've already implemented that. Great, we just dropped that in. And the second one is just what we're going to call the cycler screen component. The cycler is going to have two functions that just say, hey, go forward to the next person or go back. And when a player clicks one of those arrows, it's going to get the cycler screen and then tell it, let's say in our example, we're going forward. So when that function gets called, the cycler screen is going to take a look at its list and say, okay, here's the next character. It's going to grab the enter screen component, change the data for it. Enter screen is going to broadcast, my data's been changed, and then just everything will update. Now, we use this cycler all over the place, and one is that it's really easy for us to add. Like once we build the cycler, we kind of just can go into most of our screens, add these two components and be done. But we can also add them to screens that are very different. Like we use it here in a lot of our inventory screens, but we also do this as well on some of our screens that are much different than this one, such as the mission select. And sometimes you can get yourself in trouble with other ways of sharing work, where if you have types that are not very similar, it becomes very hard to share functionality. So here we were able to share functionality across a lot of our screens very easily. Now, we were talking about how widgets also have access to the UI components they're attached to, right? So how can we use this? As an example, this is a tooltip that we use in a lot of our screens. And we're talking about at scale, right? So this has to appear a lot of different ways, or excuse me, not a lot of different ways, has to appear in a lot of different screens. So an easy way for us to do this is that we drop this widget into whatever screen we're working with, and it has a component selector where we can choose what view component we want to listen to. And because the view component is going to give us, on click and say on focus events, that's all that this widget needs in order to operate. It's just listening for things like an on focus so it can change its data. And doing this, we're able to drop this widget into, again, a lot of different classes, a lot of different screens. All we have to do is set a drop down, and we don't need any boilerplate. So this is one of the biggest screens that we have in the game. So this is our character select. And yes, it's supposed to be big. It's supposed to be big and flashy. We're showing off the characters here. We have about 20 components on this one. So I wanted to handle a depth problem and how these components can kind of help you with that. So part of the reason why there are 20 components is because we have a lot of widgets that exist in other screens already, So we drop those in, we copy over the components that they need to work, which is usually just a data component, and they kind of just work. So in some cases, that's not a lot of work for us to do. However, by far the biggest piece of work in this screen is the characters. So we have a level here with 3 actors on them, and we need this screen to communicate with them and handle the events such as, whenever you change your hover, you're going to change the character's model, and then when you lock in, we move the camera around. So the way I did this is that we created a stage component, and this stage component was just listening to all the events coming in from the view component that our little grid here has. So whenever we got an event saying somebody was clicked, we could sort of lock in that person, play their locked-in animation, and then move the camera to the next spot. And then in that next spot, we handle all the things we did previously, like if the focus changes, we change the model. And we do that until we get to, we have all 3 characters locked in. We could start a mission, and that's where they kind of play their big "we're going to battle" moment. What I found useful about this is that I could take this kind of very complicated logic, and because it was in a component, one is that during development, it kind of kept any bugs that were happening in the stage component from kind of leaking out to other places on the screen. It tended to be just about that kind of functionality. And I found it easier to work with because I was responding to events from the view component. So I did a lot of work on this screen, so you're going to see it one last time. And you could probably see more about what I was talking about with how it's working. Okay, now I'm going to answer the question none of you have asked, which is, we've been talking about functionality here. Can you do this visually with widgets? So a lot of this comes from after Midnight Sun, so sort of that second project that hasn't been announced yet. So you're going to just have to go along with me for some things that I had to come up with and some clip art. So kind of the way that we can do this is that we have some sort of base class, like a composable widget. We can just say that it inherits from a button or something like that. In that composable widget, when you're in the design view, you're going to drop one or more widget layers. So what a widget layer is that it's an asset that sort of displays something about let's say in this case, it's an item, something about the items that you're creating. And when the composable widget gets something like a set data call, it's then going to find at runtime all the widget layers that it has attached to it and then call set data on them. So what this allows us to do is that the widget layers can all be really independent, and we can kind of put them in different configurations. So let me give you some little examples of what can be in a widget layer. So one is just an icon, right? We need to display an icon for an item. And then we've got a bunch of different assets, like we show a boost, something is damaged, one or more dollar signs for how much it costs, and how much is in your inventory. Now, one thing to be careful of when you're doing widget layers is that if you're using an asset, you kind of want to make sure you only use that in one widget layer, because if you ever update that, you want it to be in one place, right? So now let's put these together in some examples here. So let's say that in our game, a chest is the only place where you can find an item. So in this case, it's going to be the widget layer that shows the icon, a widget layer that tells you, hey, this is a new item, and then how many dollars it's worth. So we're kind of putting 3 together on top of each other. Another one is that when we look at this item in inventory, in this case, we show the item and we show whether it's boosted or not and whether it's damaged, because only items in your inventory can be boosted or damaged. When you look at it in the store, the only thing we care about is how much it costs. And lastly, let's say that you have a consumable item. In this case, we probably need to know, like it stacks, we need to know how many are in your inventory. So what we found from this is that normally what you may see is that there's one or more monolithic widgets, and then there's a whole lot of logic about what turns on or off depending on what context it's viewed in. This helps us really simplify all of our widget creation. Now, I kind of have to keep going, but there's a lot more that we had done with this. I found a lot of use of this too, also for building tooltips, so that you kind of make tooltips out of parts, put them together. Also, this was something that I still think there's a lot of stuff to figure out what are the best practices for. So I don't know, are you making a Tetris game? You can make Tetraminos out of them. I don't know. If you find something cool, let me know. Lastly, I do want to say, if you're going to go this route, make sure to talk to your artist, right? I talked about how when you do an asset, it should only be in one widget layer. But if you don't tell them that, they're going to look at your content browser and see like 15 versions of that asset and be like, oh no, my asset is in 15 different places. Life isn't worth living anymore. And then you have to like run to their desk and stop them from taking the cyanide capsule that they have in their hand. And then you'll probably have to further kind of console them by saying, hey, it's okay. I know we were talking about doing a virtual cursor in this game, but it's not 2012. Nobody should be using virtual cursors, and then they'll probably be okay. But, you know, nobody's got time for that. So just tell them ahead of time, right? Now, as we're kind of wrapping up here, not all of our screens in Midnight Suns were done using components. Very few of them, but there are a couple out there. One of them is the options menu. So the reason for this is because if you think about options menu, it's kind of a solved problem, right? We don't really have to iterate that much on it. And well, if you have to set the DirectX version in multiple places in your game, well, I got some sympathy for you, but that's rarely the case, right? All the options in your options menu, that's probably the only place where they are set. So we don't need to share functionality. Sure, we could go in and create, a data asset and say, here's the buttons for something, but it's just so much easier in this case. You can just go to the design view, drop in those buttons, put some blueprint nodes to change the settings, so just use your head on things. Now, question is, how did UICS work for us? And this is kind of taking both my experience with it as well as the Firaxis team and the team on the second project and kind of putting together all this data from talking with them. In generally, what we found is that there was less effort required to iterate after our setup, right? So we did have to build UICS, and there is some initial setup because when you're using the system, everything's data-driven, right? So that's just going to take more time than if it wasn't data-driven. But once we got that stuff set up, then we started seeing some better iteration times. And along with that, it was easier for us to share functionality across screens and handle the data permutations that I was talking about before, where you need to see a player, you need to see all players, you only need to see friendly players, things like that. Now, there is a learning curve to using the system. And in my conservative opinion, it's probably about 3 months for people to kind of get a handle on this. And the reason why is because this is a very different way of thinking about how to solve problems. And so in order to keep referencing Star Wars, you have to unlearn what you have learned. And that's what this learning curve is kind of all about. Something we found that was pretty interesting is that we had after the system was set up and kind of stable, we had a lot of good time. We had the consistency and workflow for our UI creation ended up being pretty good. We had good consistency in terms of how were our screens created. They looked very similar. And then we had a workflow that people could follow. And I'm going to call this the Garfield principle, named after everyone's lazy cat. And what I'm saying with this is that if the easiest way is also the correct way, more people are going to do that. So feel free to quote Jim Davis, the creator of Garfield, for that quote if you want. And interestingly, when we got to the end of Midnight Suns, when we were taking a look at the bugs that were coming in, we had far less defects on things that were in components than other things in the system. So some of the things we identified for that is that one is, components provide a structure and consistency like we were talking about before, and they're also very self-contained. It's very hard for one component to kind of have its functionality bleed out somewhere else. Along with that, we found that when it came to our classes, we had a lot less classes than you would expect for a project of our size. And that was because things were a lot more flat due to using components and composing things instead of inheritance. And I also feel that one of the reasons too is because most of our components do something I call read and respond. They're responding to another component when it does something, and usually all that they're doing is that they're reading something from them. There are a couple cases where that changes, but I think that also is one of the reasons why we had less defects. And this is good from Unreal's own, or I should say Epic's own documentation. 80% of the lifetime cost of a piece of software goes to maintenance. And when talking to the Midnight Suns team, we kind of all agreed that we wouldn't have been able to ship with the same kind of quality that we did for the UI without this kind of system. So just some things I want to bring up for consideration, because I believe that technology exists for people, either the content creators or the users. So just some things I want you to think about. One is, if you're deciding to switch this system, what's the cost of implementing UICS? Now, I've got a little asterisk there. We'll get to that. You also need to think about how much time will it take to kind of train people to use the system, and how big is your game or product going to be? How many screens will it have? Does it make sense to do it? And lastly, how important is iteration? If you're on a project where there isn't a whole lot of iteration required because you know more about what it is you're making, that's something to consider. Now, with all of this being said, don't forget all the good stuff that I said in the last slide as well when making these considerations. And while I put the word cost up here for cost of implementation, think of it more as, an investment. So I was talking about that little asterisk there. So one is that if you want to get these slides, there's as well as a technical write-up of kind of what I'm talking about here. If you go to this website, you'll get that. And I'm also going to be releasing a library for free called UI Power Tools. If you want to see an example of it or see a preview of it, you can go to that website. It has right now a full implementation of UICS that you can use. It will be open sourced. I haven't gotten to that part yet, but you can kind of expect that next week. So you can go there for more information. And with that, thank you all for your time. Special thanks to the Firaxis UI team, and also another team, the Virtual Cursor team. They know who they are, so thank you.